Hi, welcome back to Moose and Chemistry. This is electron configuration of francium, FR lesson. Francium is number 87 on the periodic table. All right, so we put an 87 up there, and its atomic mass unit, AMU, is 221. So now we have 87 protons because that equals the atomic number. And since it's electrically neutral, it has to have 87 electrons. Now, remember that it's AMU minus number of protons will give us our neutron count. So you go 221 minus 87 equals 134. So put 134 right there. Okay. Now let's go ahead and erase that. Of course, you guys remember, if you've gone this far with it, you know that S subshells can hold 2 electrons, P can hold 6, D can hold 10, and F can hold 14. We use a diagonal rule, which is the off-ball principle, stating we fill the lower shells first before we fill the upper shells, and we just follow it down. All right, so we go 1s2. All right. Then we're going to go to, hey, we'll circle it this time, 2s2. Then we go to 2p6, 3s2, 3p6, 4s2. Just keep sliding down the slide till we run out of electrons. 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s1. Snarls. Okay, so now we're going to do the orbital notation, which is Hund's rule. And Hund's rule, as you remember, states that you put an up arrow in that suborbit for every one of those suborbits of that particular suborbit, and then you can start the down arrow after you do that. All right, so let's go ahead and do this, okay? So we go up and down. See how easy it is? Up and down. We go up, 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 down, down, and down. See that? So we just keep on going until we run out of electrons. Remember that an up arrow electron means the electron's rotating clockwise, and that down arrow means it's rotating counterclockwise for that electron. So we're just kind of like going through here. You can whistle if you want to. Who knows? Let's just get this out. Yeah, the more electrons we get, the longer this Hund's rule gets. And it does get long. Yep, as you can tell, these are a lot of arrows that we're drawing. We're going to draw 87 arrows, man. Pretty darn snarly. Or not snarly in some cases. Yeah, these are the kind of elements that your teacher usually does not give you to do. So that's one of the reasons why I like doing it, because, you know, hey, I'm francium. Somebody use me in a chemical combination. By the way, francium is highly unstable. As a matter of fact, there's less than like 2 grams of it on the planet in one given time, so I understand. Because it is highly reactive to water. And there's a lot of water vapor on the Earth, so it doesn't really hang out too well. And it's also very violent when it comes in contact with water, like most of the alkali metals. Okay, and then 7s1 going up. Now, what's the nearest noble gas to francium? Why, it's radon. Okay, so it's Rn, and radon's electron configuration goes all the way out to 6p6. See that? That's our Rn, right? So you would just say Rn7s1. Now, Pauli's exclusionary principle talks about the quantum numbers. No two elements can have the same set of quantum numbers. So it is in the s block, right? So the principal quantum number is going to be 7. It's in the s block, so it's got a 0 value for the angular momentum. The magnetic number is also 0, and it is an up arrow. See that up arrow right there? So that's going to tell me it's 1/2 positive. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.